Hello, everyone. Welcome to our webinar today on the free puppy, how to responsibly leverage open source AI as part of our PyTorch, OSPO, and academic outreach program. I am Jennifer Bly. Great to be with you here today. I am very pleased to introduce our speaker for today, Mo McElhaney. Mo leads open source developer programs at IBM Research. For more than a decade, Mo has worked in open source, focusing on cloud data services, quantum computing, machine learning, and ethics in AI. They are on the content committee for PyCon US, a contributor to version 3 of the Contributor Covenant and Hippocratic License with the Organization for Ethical Source, and on the board of the Vermont Technology Alliance. Mo is a certified master gardener with the University of Vermont and lives in Frosty, Vermont, with their family, cats, and many plants. As we go along today, please drop any questions that you have in the comments, and we will have a Q&A session at the end. Please take it away, Mo.
Thank you, Jennifer. I am so happy to be here today. Thanks to everyone for joining. So today I'm going to be talking to you about how to responsibly leverage open source AI. And the reason that I'm calling that a free puppy is if it's not apparent, a puppy is a lot of work. And so just because it's free doesn't mean it's not going to cost you time, money, energy, frustration if you're not careful. So let's talk a bit about the structures in place to help with determining what makes an open source project a strong candidate for usage, and what frameworks are out there to help you with responsibly leveraging open source AI, because this is, a very lively and active space that is currently still being defined in real time. So just to kind of jump into a high-level overview of what I'm going to talk about today. We'll talk a little bit about the history of open source, how you can choose an open source project. We'll talk about what is open source AI, what sets it apart from more traditional systems that are black box, closed source. And then why there's some controversy swirling around the definition of open source AI and how that's developing. We'll talk about some Linux Foundation resources that are available, and what else you can do in this space. So first, I work remotely. This is my cat. I'm going to put her down now. I work remotely from home. I live in northern Vermont. So if you're familiar with the United States, I'm in the top right-hand corner. The closest major city to me is Montreal. I am an open source developer advocate and open source contributor. I've been working in this space for over a decade and many different communities, and watching this space transform, especially over the past couple of years, has been very exciting. I work in IBM Research, focusing on open source AI. I'm a community architect, and I also shepherd open source more broadly for the entire enterprise here at IBM. So I'm an admin for our public GitHub organization and help maintain our internal documentation around how IBMers engage in open source, trying to make that be a good, healthy space where IBMers are leveraging open source and also giving back to make it holistic and to put our money where our mouth is, So some of the things I mentioned in this talk are my opinions. I'm not necessarily an official representative of IBM's official stance on all these things. All of these things I'm talking about are based on projects that exist out in the open, or based on my own experience and professional opinion. So let's talk a little bit about the early days of open source because this really impacts how we define open source AI. And so the early days of open source, there were a lot of debates about what constituted an open source project. There was a clash between the Free Software Foundation, who developed the new general public license. They wanted everything to be accessible and distributed using copyleft licenses that forced people to say that if you are using our code, then you have to make your code available too. So the open source initiative was created as a reaction to this to say that, this is fine, you can do that. But here is an alternative because a lot of companies want to leverage open source and decide what things they are going to open source and what things they are not. And they want to be able to make some money off of the software that they're developing while still leveraging and contributing to open source projects that are important to them. So the term open source was coined as a counterbalance to free software. So yeah, this slide shows the 4 freedoms that are set in place by the open source initiative. And then you can see a chart of the most popular open source licenses that still exist today and are still in wide use. So now that we've got this history of how open source was founded, let's talk a little bit about how this moved into artificial intelligence and the development of this space. So initially, AI was very software oriented. But now, as we've seen, it's moved into being very model driven, which is quite different in nature than how software programs work. And so now we're in this murky area where we don't exactly know which way the industry is going to go. Companies that started working in the open with the goal to remain in the open have moved into a more closed model of AI models. So we see thousands of models being distributed for use on Hugging Face, but if you look at the licenses there, they all fall very short of being a permissive license that would be expected from an open source software. The Open Source Initiative, who has been in the business of defining open source software for many years, decided to identify which AI model licenses are actually qualified as open source licenses by respecting open source freedoms. And in October of 2024, the Open Source Initiative announced their open source AI definition. And that was the culmination of efforts of many, many people, many, many debates. And, it's going to continue to evolve because of that continued debate that's happening. So let's talk about some of the challenges that still exist in spite of this new definition. So in the attempt to define open source AI, there were many heated debates, what sort of license is acceptable for this type of technology. What we're seeing is there are many, many, many different licenses being leveraged out there. And so, for example, if you look at the Llama Community Agreement, which is built by Meta, it says that you can do whatever you want up to a certain level of usage, like a certain number of users per month, which might work for many different use cases. And that number may be pretty large, but this makes this not permissive as an open source license because you're limited on the users. And there are other licenses that have restrictions that are well intended, such as the Rail license. It's a responsible AI licenses, which seek to prevent irresponsible use and harmful applications. So you can leverage these models, but you can't use it for military applications, for example, which makes them difficult to adopt in enterprise settings where government contracts are commonplace. So while this is obviously well intended, it's not permissive because you only have permission to use it in specific scenarios. The next challenge that's caused by this is the fact that models are not source code. They're typically a bunch of data. And so the problem is that if you go to Hugging Face, any model you pick will hopefully have license info there, but they're often completely custom. They're built off of software licenses, which are not the same thing. And in fact, models aren't just made of software. So in a model, you have source code, you have model architecture, along with the data and the weights. So you can't really just apply a software license to a data set. It just doesn't work. It's not one for one. So for your data, you can use something like the CDLA or OpenMW by the Linux Foundation. So, how do you license them? That's the next big challenge. As of March 2024, OSI considered making a dual definition approach. They would have an open source AI definition and then an open science AI definition. And the key distinctions between these two is that an open science approach would have an academic focus. It would be all about knowledge sharing and transparency. And then an open source focus would be looking more at the practical applications and industry adoption. So it's possible that a single definition will never work because there is natural and healthy, in a lot of cases, conflict between restrictive versus permissive community needs. And in open science, completeness refers to providing comprehensive and well-documented information for all of the components. So that ensures that each element is thorough, self-contained, and meaningfully usable without requiring additional context or resources. And then when you're thinking about openness, there's the binary property indicating whether a particular component is licensed under an open license or not. And so a component is considered open if and only if it's distributed under a license that grants users the rights to freely access, use, modify, and share. So if a component is not licensed under an open license, it is not open. What we've basically seen as a result of the OSI open source AI definition is that basically not a lot of people are very happy with it. And they will tell you that too. So they're, continuously working. I'm sure another version will be out at some point. And so there are many challenges that remain, including the rapid number of growing available models that are out there, a lot of open washing, people saying they are open, but not actually meeting the industry definition of open source, many licenses with acceptable use policies, no consistent definition of open, a lack of understanding about license implications, and many components that are not actually released. For example, the data sets as part of the models. There are also illegally converted licenses out there. So a license that's ripped out, changed, and then not really properly attributed there. Open source licenses that are made for software used on non-software without any kind of changing them to accommodate what's actually being pushed in the open by these AI models. And user agreements used on model weights and that kind of thing. So there has not been very much adoption of the OSI definition due to all these remaining challenges. So the generative AI commons at LFAI and Data Foundation was designed and developed the model openness framework as an answer to this. It has a 3-tiered classification system for evaluating, classifying the completeness and openness of machine learning models, promoting transparency, reproducibility, and usability. This framework assesses which components of the model development lifecycle are publicly released and under what licenses, ensuring an objective evaluation. And then built upon this is the model openness tool. So that's used to implement the MOF. And the tool evaluates each criterion from the MOF and then generates a score based on how well each item is met there. So the MOT provides a practical, user-friendly way to apply the MOF framework to your model and produce a clear self-service score. So how it works, the MOT presents users with 16 questions about their model. Users need to provide the detailed responses for each question. And then based on these inputs, the tool calculates a score, classifying the model's openness on a scale of 1, 2, or 3. So here are the 17 components. They're kind of split into 3 separate categories here: code, data, and docs. So you're looking at them separately, but they all relate to the overall openness of the model. So for code, you're looking at model architecture, pre-processing code, training code, inference code, evaluation code, and then also what libraries and tools are leveraged within this. For data, you're looking at model parameters, the training data sets, evaluation data, the sample model outputs, model metadata, and then there's, the config file for the model openness framework in there as well. And then documentation is also really important. Is there a model card? Is there a data card? Is there a technical report, a research paper, and then also the evaluation results? So to be considered open, every single component must have an open license, a license allowing unrestricted usage, study modification, and redistribution for any purpose. Every component should also have a type-appropriate open license. So it should have an open license that is appropriate for the type of component it is covering, be it code, data, or documentation. And some examples of licenses that work there for these different components. So for example, if you had a model and the code was covered under an Apache 2 license, the data was covered under a CDLA permissive 2.0 license, and then the docs were covered by CC by 4.0. That would be considered open because all of those components have those particular licenses that are appropriate and cover what you need there. So some references to what we discussed here. The Model Openness Framework paper is really helpful for offering guidance to researchers and developers seeking to enhance model transparency and reproducibility while allowing permissive usage. There have been a bunch of updates to it since it was released in March 2024. There's also the MOF specification that provides a concise definition of the various classes and focuses on the what rather than the why for what you have. And then the model openness tool is functional now with over 200 models, and you can check that out at isitopen.ai. That's where that QR code will take you if you leverage that there. Special thanks to my colleague Arnaud Lahore, who is the Generative AI Commons co-chair and helped me a bunch with some of the things for my slides in this presentation. And then some additional considerations for you to think about when choosing an open source AI project to get involved in. The MOF scope is limited and doesn't address many other aspects that are really important, like AI safety, including bias, fairness, and trustworthiness. Security and privacy and performance are 2 other metrics or areas that are really important to consider and not quite covered there. So there are many efforts out there to define these things and make them easier to leverage. So there is, in addition to the OSI definition, there is a European Open Source AI Index. There's a Stanford University Foundation Model Transparency Index, the Gen AI Commons Responsible Generative AI Framework, RGAF. I've contributed to that project as well. And that's another one that has 9 dimensions, and you can kind of use that as a guide to evaluate things. And then I mentioned earlier the responsible AI licenses that exist as well. So those are all sort of additional tools you can utilize to evaluate open source frameworks that you might want to leverage. So that's what I have for my presentation today. You can utilize these 2 QR codes. The first one will send you to the Model Openness framework, so you can poke around in there and use that to evaluate some open source projects that you're working in. And then the Responsible Gen AI framework, you can get involved with that. That is, these are both open projects through LFAI and data here at the Linux Foundation. So they, they're always looking for more people to get involved. You can join those meetings and learn more about what they're working on currently. And hopefully this helped, help you think a little differently about open source AI as, maybe it is a free puppy, but you can still have fun with it. And as long as you have the right tools and really think honestly about your capacity and the risk involved with adoption. So thank you. That's the end of my official presentation. I would love to stick around and take any questions or participate in any discussion around this topic. But yeah. Okay, I am popping into the chat now, just to see what questions, if any, have come in. It's like there's some good. So the most recent question I can see, I have question, how can I choose the right open source project as a beginner? That's a really good question. What I'm going to do is I'm just going to go to a specific project. And this is not a project I'm necessarily saying you should get involved in. I mean, you obviously could because it's an open source project, but just so when you're looking at an open source project, you can have an idea of what to do when you're first jumping in. So if there is a particular project that you are leveraging, like PyTorch, for example, I'm going to look at IBM Granite because that's a project I helped to open source and I've contributed quite a bit to behind the scenes. So if you wanted to get involved in a Granite project, let's look at the time series models. So the first thing that I do is I look, if let's say I'm not familiar with this project at all, what I want to do is I want to look to make sure it has a strong license. So I know that it's open source. I can contribute to it. I will be credited for the work I'm doing. I can leverage it for the things that I want without getting in trouble legally. And then what you might want to do is take a look at the project to see, okay, what's in the README? Does it have an initial setup steps? Are there steps to getting the notebook installed? Are there any tutorials? Really, when you're getting started with a new project, you want to see what resources are already there that will make it easier for you with getting started with it. And so a more established project is going to have demos that you can use. It's going to have Google Colab tutorials. It's going to have a contributing document, which this particular repo doesn't have it contributing. But if it had a contributing doc, it would show up here automatically in the About Me section for the project. You can also see that it has standardized release numbers. So that means you can see easily when was the last time the project was updated. All those things just tell me there are human beings who are actively working on this stuff and will respond to my questions when and if I have any. Another thing you can do when you're getting started with a new project is see where that community has their discussions, where they are actually engaging, and look to see, okay, are there actually people utilizing this? When was the last time? Is anybody actually responding to the questions that come in here? Those are all good indications that it's an active project. There are human beings who are actually watching these things and are there to help you when and if you run into issues. So aside from all that, once you know what project you want to get involved in and you just want to get started, great place to start is the issues. And one thing you can do is look to see if there are any good first issues. So you can click that. And then it should sort up. This project doesn't have any good first issues, but I could have planned ahead and planted myself into a project that had that, but you can look to see if a project is leveraging good first issue tags. And if not, either way, just look through the issues to see if there's anything that is easy that you can pick up and work on. And a lot of times the best place for you to start when you're getting started on a new project is just read the documentation and then see if there's any glaring issues that you can help the project with. Maybe you're just fixing typos, but it shows the project maintainers and the contributors and the community that you care, that you're actually reading the docs before you're starting to, refactor a whole bunch of code. What you don't want to do is just jump in, take an issue without interacting with the community at all. Because you might like do a bunch of work and submit a PR, and that community is just like, we already had that handled. Someone else is already working on it. So the best thing to do is to get involved, see if that community has community calls that you can join. Like, for example, I think there's a VLM community meetup happening right now. That's another project I'm involved in. Go to their calls and see what kind of stuff they care about, what kind of stuff they're talking about, what kind of issues they have. And that's where you can really find out where they need the most help and jump in and feel useful, feel like you're really using your time. So, did that answer your question? I hope that was helpful. Let's see. Be interested to hear more about your experience with IBM Granite. Were there some significant hurdles or lessons learned? Yeah, Granite has been quite an undertaking. We just announced version 4 of Granite that includes the nano language models. So as we're seeing across the industry with large language models, people are realizing you don't always need a chainsaw when all you really need is a butter knife to solve a problem. So that's been our big evolution with the Granite Foundation models, is having those big models with billions of parameters is really great when you need that. But there's so much you can do with smaller language models that still carry the same weight and the same impact. But yeah, that's it's a very, it's a general question. So, yeah, if you have more specific questions about that, I'm happy to chat about it. I just use that as an example there. Um, I'm just looking at the questions here in the chat. All right, so Virginia, I work in an OSPO, so I was curious about it from a compliance perspective. Or as an example of an open source AI project. Oh, specifically for Granite. I didn't mean to make this call about Granite. I just use it as an example. But yeah, Granite, the thing for us that set Granite apart was really that it was unique because it was the first model of its kind, set of large language models that were released under an Apache 2 license. So we made it fully open source, and that was a big undertaking to make that happen. And it was unusual across the industry for that to be the case. So um, making it possible to leverage something like this in heavily regulated environments was important to us because, we're coming from an enterprise kind of landscape. So, yeah, in thinking about it as an example, thank you, Virginia, of an open source AI project, that's really the perspective we were coming from. How do we make it as transparent as we can? We still focused on the models in open sourcing the Granite set of foundation models. The data is not necessarily something that we own or that we open sourced, but we're transparent about where the data is coming from, which is also unique across the industry when you're looking at foundation models. So those were two things that were central to our strategy around making those open source. Any other questions? Okay. I think that's it. Thank you so much for everyone for joining. I hope this was useful. Jennifer, if you're hanging around, I
Yeah.
think that's my cue.
Yeah, thank you so much, Mo. We really appreciate it. Thank you for walking us through how to responsibly leverage open source AI. And thank you to those of you who dropped questions today and joined us for this discussion. Be sure to visit the PyTorch website at pytorch.org, subscribe to our newsletter, follow us on social media, X, LinkedIn, Facebook. So you'll be the first to know about upcoming webinars and our future PyTorch OSPO and academic outreach programming. Thanks again, Mo, and thank you for joining us. Have a great day. Bye-bye.
Bye.